begin with videos on conics. 174 conic section VI video number 2. Okay, once again we're looking at these problems. We've done the circle and the ellipse problem. Now we're going to do the parabola first and then the hyperbola. So if we look at what's information here, we have a vertex given and we have a directrix, which is this line down here below the y-axis at y equals negative 1.25. You also have your handout everything you want to know about conic sections, but we're afraid to ask. Parabolas, we have two different varieties. The type that open up or down would be this number 2 here. Okay, and so this is a parabola that opens up. Y minus k equals 1 over 4p times x minus h squared. Very similar to the graph of y equals x squared. Okay, so let's start there. We've got y minus k is 1 over 4p x minus h squared. And again, the pertinent information, hk, for the circles and the ellipses, that was the center. Well, we don't have a center of a parabola, but we do have a vertex, which is the turning around point. And the last thing we need is this p number, and this will be our focal distance. Again, focal distance. Okay. The other sheet I've given you is this one here, a river and well problem. We'll talk about this one briefly on Thursday night. This is an exploration into the idea of focal distance and eccentricity and focus and directrix. So we'll talk about this one a little bit in class, but what you'll learn when you do that is if you have a parabola, then you effectively have a focal point and a directrix. And for parabolas, these distances here between the vertex and the directrix and between the vertex and the focus, those are exactly the same. Okay, so here's our turnaround point. There's our vertex. And the focal distance, I'm calling this p. So whether you call it that p or this p, they're the same p. Okay, let's go to our problem, see what we know. We were given in the information the vertex, so we know h and k, that's 2, 1. So 2 is going to go here. Remember, the h goes with the x, and the 1 is going to go there. Right now we're at this stage, y minus 1, 1 over 4p, x minus 2 squared. And our only task is to figure out the focal distance. Well, if you look at the picture, let's see if I can redraw this a little bit. We have the parabola with the vertex given. This is the ordered pair 2, 1. And we have the directrix down here at y equals minus 1.25. So we need to figure out this distance. And again, you can use the distance formula, but it's a vertical distance, so you don't need to do a triangle. 1 up and negative 1.5 down. This p is negative 2 point, let's see. This p is equal to 2.25. It is a distance, so I'm going to call it positive. Okay, 2.25. And maybe I can write that a little bit cleaner. That's 9/4. Okay, so that's our p value. We'll put that right here, 9/4. Obviously, the 4's cancel. And we're done with the problem. Y minus 1 is 1/9 times x minus 2 quantity squared. Okay, just like with the ellipses and the circles, you might find this in a general form. I don't particularly like the 1/9 there, so let me multiply both sides by 9 just to clear the fractions. Okay, so we have 9y minus 9. Multiply both sides by 9, and we have x minus 2 squared. Cleaning things up a little bit further, 9y minus 9, x squared minus 4x plus 4. And again, usually we'll move all the quadratic terms to one side. X squared, there is no square on the y. So now we can do the linear terms, minus 4x. I'll move the 9y over, minus 9y. And all the constants, let's see if we put that over there, that would be 13. So plus 13 equals 0. There's our sort of general form for this particular parabola. And just like what we did with the circles and the ellipses. Suppose I gave you that and you didn't know anything else. Could you find the vertex and the focus and the directrix? Okay, so the first thing you note is that if we play with this a little bit, I can make it look like x squared equals y by just moving that over there. Now technically it's 9y, but you see an x squared and a y equals x squared. I know this is opening up. So this is a opening up parabola whenever you have a y equals an x squared. Okay, so and from there I got y minus k is 1 over 4p times x minus h squared. So I just have to find the h and the k and the p, and just like with the other ones, we're going to complete the square. So I've got x squared minus 4x, leave a gap. On the other side, I'll put the 9y minus the 13. Okay, 9y minus 13. Let's complete the square. Half of negative 4 is negative 2, squared is plus 4. We add plus 4 here. So now we do have our perfect square. This is x minus 2 squared. And over here we have 9y minus 9. I'm trying to get it to look like this. Okay, look like that. So I have to isolate the y. So let's do 9 times y minus 1 is equal to x minus 2 quantity squared. And lastly, divide by 9. So 1/9 x minus 2 squared is equal to y minus 1. And there you are. That gives you the vertex. It also gives you the focal distance. Now we have to remember that this number right here is the same as this number, focal distance. So if we write 9 is equal to 4p, our focal distance, p, is going to be 9/4, or if you want 2.25. And when we go graphing this thing, here's sort of the quick sketch of the graph. We have the vertex is at 2, 1, 1, 2, 1. We know the parabola opens up, so it's opening up something like this. And we also know the focal distance is 2.25. So if I go up 2.25, that gives me my focus. So that would be at 2, same as the vertex. But now I have to, this distance is 2 1/4. So that will be 3.25, right, because this was 1. And then my directrix is going to be the same amount below the vertex. So this distance is going to be 2.25. And because we were at 1 here, we would just go down, and this is y is equal to negative 1.25. Okay, so there's our sketch. And we can get some other points as well. But sure enough, we do have our parabola opening up like that. Okay, on to the hyperbola. So last problem on the page, we have this hyperbola. This hyperbola has what's called the transverse axis. The transverse axis is the one that connects the two vertex points. That's horizontal. And so by looking at everything you want to know about conic sections, but we're afraid to ask, for hyperbolas, you'll note that, here we are, if the hyperbola opens left and right, this case here, this is where the transverse axis is horizontal. Transverse axis is horizontal. So we're going to have at this first form where we have x minus h squared over a squared minus y minus k squared over b squared equals 1. Hyperbola opens left and right. Okay, so let's go ahead and we have the vertex points. First of all, let's go ahead and do the x minus h squared over a squared minus y minus k squared over b squared, and that equals 1. Okay. By counting in from the vertex points, you'll note that the center, the HK, is at 1, negative 2. So HK is the center, and that's going to be at 1, negative 2. So we can put those numbers in. X minus 1 squared. Leave the a squared just for a minute. Y minus a minus 2 would be y plus 2 squared over b squared is equal to 1. Okay, the length of the transverse axis. Okay, so here's their hyperbola. This is the transverse axis. That length is 2a. It's sort of akin to the major axis in the ellipse. And again, we have these points given, so we can just count the boxes. 1, 2, 3, 4. This is 4. So 2a is 4. So a is 2, and a squared is 4. We have the bottom of this term. X minus 1 squared over 4. Y plus 2 squared over b squared equals 1. Okay, we just have to calculate the b squared. And just like with the ellipse, there's a formula that ties together a, b, and c. Here it is. A squared plus b squared equals c squared. C being the focal distance. Focal distance. Distance from the center, here's the center, all the way out to the focus. Let me use a blue color here. This is our focus point out here. So this distance is c. And for this problem, that's given. If we, again, we count the boxes, 1, 2, 3. The focal distance is 3. So we have 3 squared. We don't know b squared. We do know a squared is 4. Right. So let's see what we got here. A squared. So 4 plus b squared is equal to 9. B squared is equal to 5. And that will go on the bottom right there. Okay, so here's the graphing form for our hyperbola. X minus 1 squared over a squared. Y minus 2 squared over b squared, and equals 1. Okay, so done. We have the equation of the hyperbola. And just like in every other case, I'm going to, ask the question, what happens if I gave you this and you didn't know anything? Could you find the center, and could you graph the hyperbola? Could you figure out what's going on? Okay, so, well, here it's already in graphing form. Let's suppose I got it out of graphing form. Multiply both sides by 20. X minus 1 squared over 4, y minus 2 squared over 5 is 1 times 20. Okay, so now we have, let's see, 5 in the first multiplication. 5, x minus 1 squared, minus 4, y minus 2 squared equals 20, or expanding, we have 5 times x squared minus 2x plus 1 minus 4 times y squared minus 4x plus 4 equals 20. And then again, distributing just to make this look more standardized. 5x squared minus 10x plus 5 minus 4y squared plus, this was a y, Joe, 4y when I expanded that. Okay, so minus 4 times minus 4y is plus 16y, and then minus 16 equals 20. And lastly, we'll rearrange it so the quadratic terms are first. 5x squared minus 4y squared minus 10x. Here's the linear term, 16y. Our constants, what have we got? We've got minus 11 and then minus 20, so minus 31 equals 0. I think I did that right. Okay, 5 minus 11, or 5 minus 16 is minus 11. Take away 20 minus 31. Okay, so here, I give you this. This is the general form. Could you complete the square to get it back in graphing form? And the answer is yes, you can. So very similar to the ellipse process. Let's see how this goes. 5x squared minus 10x, leave a gap. Minus 4y squared plus 16y, leave a gap. Throw the 31 across. Go ahead and factor. 5 times x squared minus 2x, leave a gap. Factor out a negative 4, so we have y squared. Be careful here, this will be minus 4y, leave a gap. We still have 31. Okay, let's fill the gap. So half of negative 1, or half of negative 2 is negative 1. When we square it, we get 1, and we add the same amount to the other side. Right? Again, remember this 1 is in this parentheses, and it is multiplied by 5. That's why I add 5 on the right. Okay, for the y, half of negative 4 is negative 2. Squared is 4. and add the same amount to the other side. That would be minus 16. Again, the 4 is in the parentheses, but it's multiplied here. So we really change the left side by minus 16. We have to change the right side by minus 16. Okay, getting close. We have 5 times x minus 1 squared minus 4 times y minus 2 squared equals 36. Take away 16 is 20. And then we'll go and divide everything by 20 to get it in our graphing form. So x minus 1 squared over 4 minus y minus 2 squared over 5 is equal to 1. Okay, the x squared term is the positive one, the y squared term is negative, so that opens left, right. Okay, hopefully this will be useful. You might want to watch it 1 or 2 more times. Let me go ahead and stop this guy here, and good luck.